You know what if I told you that the slow, elegant way wine drips down a glass and the very way our living tissues hold their shape are connected? It sounds kind of wild, right? Well, today we're going to pull back the curtain on this incredible piece of physics that links them both.
Okay, let's start with something you've probably seen before. You give a glass of wine a good swirl, you set it down, and then you see them, these clear little droplets, what people call tears or legs, clinging to the side before they slowly slide back down. And this isn't just some random thing. It's a signature of drinks with a decent amount of alcohol, and it's fascinated scientists for, get this, over 150 years. So the real question is, what in the world is the force that's making this liquid climb up the glass against gravity?
To get our heads around this, we got to talk about something called surface tension. The easiest way to think about it is like an invisible skin on top of a liquid. See, molecules deep down inside are getting pulled on equally from all sides by their neighbors, but the molecules right at the surface, they're missing neighbors above them, so they get pulled inwards much more strongly. And that creates this tight, cohesive layer.
This image here shows you exactly what's happening at that molecular level. See those guys at the surface? They're getting yanked down and sideways, creating that elastic-like sheet. And that powerful inward pull is what makes liquids try to have the smallest possible surface area. It's exactly why tiny water droplets want to be perfect little spheres.
Which brings us right back to our wine glass. Okay, so surface tension explains the skin. But what's making that skin defy gravity and actually crawl up the side of the glass? Well, the answer isn't just surface tension itself, but a difference in surface tension.
And this, right here, is the key. It's called the Marangoni Effect. It's a really simple but powerful idea. Basically, whenever you have a difference or a gradient in surface tension, the liquid gets pulled away from the area of low tension and towards the area of high tension. It's like a tiny microscopic tug-of-war.
So let's put all the pieces together for our wine mystery. First, you swirl the glass, and that coats the side with a thin film of wine. Second, the alcohol evaporates from that film way faster than the water does. Third, that creates our gradient. The film becomes more watery, which means it has a higher surface tension than the wine in the bottom of the glass. Fourth, the Marangoni effect kicks in, and that high-tension film literally pulls more wine up the glass. And finally, when enough of that liquid piles up, gravity wins, and it all slides back down in those famous tears. And there you have it, mystery solved.
But here's where our story takes a really fascinating turn. I mean, it's easy to write this off as a cool little party trick, a fun bit of physics. But what if this exact same principle was fundamental to the mechanics of life itself? Well, it turns out that researchers are finding that living tissues also have surface tension. It's one of the key forces that helps them hold their shape, move around, and even react to what's happening around them. But as you can probably guess, there's a huge difference.
Check out this quote from a 2022 research paper. It says, "The tension in living tissue comes from the generation of non-equilibrium active stresses." Okay, that's a mouthful, but the key word there is active. Unlike the wine, this tension isn't passive. It's generated on purpose by the cells themselves. And that's what scientists call active surface tension. Inside every one of our cells, there's a scaffold called the cytoskeleton, and all over it are these tiny molecular motors. Think of them as little engines. They burn chemical energy to actively pull on the cell surface, creating tension. It's the difference between the wind just passively pushing a sail versus an engine actively spinning a propeller. Totally different game. So this led scientists to ask a really brilliant question. What would happen if you could create a surface tension gradient in a living tissue, just like the one in the wine glass? Would you see some kind of biological Marangoni effect? So to find out, they took a small clump of cells called an aggregate, and they used a super precise laser to zap a few cells right on the surface. By doing that, they instantly destroyed the active motors in that one spot, creating a little patch of low surface tension. And the result? It was incredible. On the left, you can see the very moment the laser hits, the cells immediately start moving in this powerful, coordinated flow, pulling away from that spot. Then, just to prove it was the active motors doing the work, they did the same experiment on cells where those motors were blocked with a chemical. And on the right, you can see the result. Nothing. Absolutely no movement. And this motion was unbelievably organized. The cells on the surface flowed away from that low-tension spot, while the cells deeper inside actually moved towards it. This created this perfect, circulating flow pattern, kind of like a donut rolling in on itself.
It was a Marangoni-like flow, but it was happening in a living, almost solid material. But then, something happened that you would never, ever see in a wine glass. After that initial rush of movement, the entire flow slowed down, stopped, and then it spontaneously reversed. The cells flowed right back to where they started from.
So why did it do that? Because the tissue is alive. The cells around that damaged spot actively fought back. They worked to rebuild the tension that was lost and restore their original shape. The researchers have a great name for this: surface tensional homeostasis. It's this deep, fundamental drive that living things have to keep themselves in a stable, balanced state.
So this slide really breaks down the huge differences. In wine, the flow is totally passive, driven by evaporation, and it's irreversible. It happens once, and it's done. But in the cells, the flow is active, driven by cellular motors, and it's spontaneously reversible. The cells fight back, behaving more like a stretchy solid than a simple liquid.
And that right there is the big takeaway. A physical principle you can see creating pretty patterns in your wine glass is also a major player in the fundamental mechanics of life. This active, Marangoni-like motion is part of how our tissues can respond to damage, heal, and maintain their shape and their integrity. It really makes you wonder, doesn't it? What other huge secrets about how life works are just hiding in plain sight, waiting for us to notice them in the simple physics of our everyday world?